Good morning, or shall I say good afternoon. Of course, it's morning over here on the East Coast here. On the West Coast, those that are viewing us right now, welcome to our broadcast. I am with MBL Entertainment, and this is our show based on the Habitable Zone. Like I said before, I am Mark. We're going to have something interesting going on. So I'll be your host for this broadcast. I'd like to welcome all of our viewers and invite them to ask questions in our comment section, and we'll try to get them up on the screen for everyone. Bear with me here. I just want to check, make sure you guys are hearing me, and obviously you are. I have the honor during this broadcast of presenting science fiction and science fact to show you the differences and the similarities, and to explain to you the possibilities of things we are currently seeing on programs such as The Expanse. To help me do that, we have enlisted the aid of some of the most intelligent people associated with those categories. Please allow me to introduce to you a couple of NASA scientists, an amazing actor, and as my co-host, a visual engineer from the era of Star Trek. So let's meet them. Stand by. Let me go ahead and bring up my good buddy here. And stand by. Hello, you guys do or do not recognize this. This is Rick Sternbach. He's an illustrator who is best known for his space illustrations and his work on the Star Trek television series. Hey, Rick, how you doing, buddy?
Good morning. Good to see you.
Hey, thank you so much for joining us on this broadcast. We're going to try and go through a solid hour, and we're going to go through it quickly. And like I said previously, if there's anyone that is in our comment section, you guys go right on ahead and go ahead and type your question. Oh my God, they're popping in already. Let me go into my next. Dr. Robert Hurt. He's an astronomer.
Hello there.
Hey, hold on. He's an astronomer and astrophysicist. You made that word up, Robert. Whose work at Caltech IPAC centers around visualizations created in support of science communications and education. He is also the writer and the director of The Habitable Zone, a video series exploring the science behind exoplanets, featuring Cas Anvar and Kara Gee. Hopefully I pronounced her name correctly. How are you, Robert?
Doing well here. And in fairness, the term astrophysicist was coined by my friend and colleague Frank Summers at Space Telescope Science Institute, but he offered it to the community for anyone who felt it described what they did.
Oh, excellent. Okay, and let's bring up our next scientist. Welcome, welcome, welcome. And let me, 3, 2, 1, she will be popping in, and there she is. This is Dr. Dawn Gelino. And
hi, everybody.
She's an astrophysicist at the NASA Exoplanet Science Institute, who specializes in the search for and study of exoplanets. She also co-leads the Nexus for Exoplanet System Science, Nexus, NEXSS, of course, which is an initiative, the NASA Research Coordination Network dedicated to the study of exoplanets as potential habitable and inhabited worlds outside of our solar system. Doctor, how are you today?
I'm great. How are you doing?
Oh, I'm fair to middling, as they say in the East. And of course, we have Rick. Rick will help us co-host on this. And what we're doing, we will have Cas pop in. He will pop in shortly as soon as he gets all his systems occupied. But this gives us enough time to go ahead and talk about these worlds. Rick, I understand that you are a stern fan of the show The Expanse. Is that correct?
I became an instant fan. You know, as soon as I started watching, you know, season 1, you know, it's not Star Trek and it's not NASA style, you know, current space exploration. It's in between, and it's, you know, internally fantastically consistent, great stories, great hardware, and I just jumped right on board.
Oh, excellent. And I guess I need to ask my doctors here, how in fact did you get, if you are in fact infatuated with The Expanse, what is your connection with the show? How did you meet Cas? Give us the whole rundown. I'll go ahead and start with you, Robert.
Sure. Well, I guess I've been there since it came out of the gate on Sci-Fi Channel. I'd heard a lot of buzz about it and immediately fell in love with the show. I mean, I watch a lot of sci-fi. It's kind of the inspiration I had growing up to put me into astronomy to begin with, but definitely appreciate a show that respects things like accelerations and tries to do a realistic portrayal. I mean, like every time a ship turns around and is actually decelerating while it is arriving at its destination, I get like goosebumps. Like nobody else actually ever shows that right. So, but I actually had the pleasure of meeting Cas a couple of years ago now. He and some other cast and crew from the show were at Caltech doing a panel on the science of the expanse. And I had the really good fortune of moderating the panel. And since then, managed to run across Cas and his colleagues at I guess we were at Yuri's night last year and a few things like that. So
let's hear it for the flip and burn.
Well, hey, without any further ado, ladies and gentlemen, look who we have here. Cas Anvar, how you doing, my friend?
How you doing? Doing good.
Long time no see.
Taking a little break from the Berlin Film Fest to talk to y'all.
Oh, well, this is fantastic. Good to have you here. And of course, you are logging in from Germany, which I'm assuming it's about 6:02 p.m. over there right now. Am I correct?
That is correct.
All righty. Well, we got a lot of people are popping in to comment. People are saying hello to you, saying hello to everyone.
Hello, everybody. I love you very much. Thank you for being there. Can't wait till you guys get your eyeballs on season 4.
Oh my God. Okay. Doctors, before we get into you, let's go ahead and talk a little bit about season 4. Let's go ahead and talk about the last 3 seasons, and hopefully we can get some spoilers.
Talk about it.
We have money, Cas. We got cash for you. So
you got cash. Okay.
Yeah.
That's a different thing.
We'll try to get whatever we can out of you right now, but let's go ahead and talk about the 3 previous seasons, which many of us, I'm sure the majority of us have already watched. Some of us who have not caught up on season 3, you might want to turn this off because you may be involved in spoilers as we speak. Cas, you are the heart of the ship. Okay, this is my impression of how I feel about you in terms of heart of the ship. It seems like you keep everyone in sync, in control. Recognizes their consciousness and so on. Is that in fact a part of you in real life with your family, or with your coworkers, etc.?
I mean, it's definitely what they wrote into the character. It's what they wrote into the show. I would say that Alex and I share a lot of commonalities. He's the most normal of the Rossi crew. He has the least kind of crazy backstory of everybody. He's a family man. He's going through the divorce. He's got a wife and kid, and he's just struggling with the life of a military man away from home who loves his job and identifies his identity is wrapped up so much in his job that he can't really figure out how to do the family life, as opposed to some of the much more dramatic and damaging backstories that his crewmates have. So he is the most normal of the crew, and he does try to keep his family together, his new Rossi crew family, and that does kind of come from me as well. It's definitely written into the story, though. The writers made a point of actually saying, Alex is the heart of the Rossi. He's the glue that keeps the family together, and I'm just lucky enough that that's something I identify with.
Well, we appreciate your role on the show. I'm rewatching all of the seasons. Actually, I'm going backwards. I'm finishing up on season 3, although I've already seen it before. I thought I'd go back into it. Let me ask you, how did you get hooked up with the Habitable Zone? What is it? Oh, by the way, Dr. Gelino, you have a message.
I have a message.
Yes. You want to explain that?
No, hang on. Sorry, I have technical support here.
Yeah. It says your name should be Dr. Dawn Lieber Gelino.
Oh, that's my maiden name is Lieber. So no, Dr. Dawn Gelino is just fine. Don't worry about it.
I thought someone was correcting me. Back to my question, I guess for all of you guys, Cas, Robert, Dawn, how did you get Cas involved in this? What was the idea behind it? Anything you can tell us?
Well, I've been, since doing The Expanse, I have been really fortunate to have been invited to and part of all sorts of scientific gatherings. The very first of which I think was the Caltech one, the Science of the Expanse panel that I helped organize with my sister-in-law, who at the time was running the PR department of Caltech, Farnaus Kadem. And she and I talked and said, wouldn't it be great if the people from the Expanse and the scientists from Caltech got together and talked about the science of the Expanse? And I said, yeah, and we organized it, and it was awesome. And I met all these great people, some of these people who are talking to us today, and we just connected. And then I got invited to things like Yuri's Night. Then I got invited to, I met a gentleman named Rick Tomlinson. He kind of connected with me, and the Expanse won the New World's first Space Cowboy Award last year, where we were honored as the most accurate representation of the future on television or film. And then, you know, it just kind of like cascaded from that. One event led to another. It's a very small, tight-knit community. Everybody knows everybody. And then when I started kind of appearing at these various events, I guess they don't get a lot of actor types in there. So I was kind of like a little bit of a black sheep in the science community, and people started talking to me, and I'm very scientifically oriented, and I think that kind of was a nice surprise for people, that they're talking to an artist who actually knows about science. And one thing led to another, and finally I got I can't even remember who asked me. Who was it that asked me about? Was it you?
It was me. I think it was. I think it was actually at Yuri's Night. I sort of floated the idea because we had been thinking about that offline for a bit. So
that's right. We were at Yuri's Night, and he said we're doing some educational things that are going to be talking about the TRAPPIST system planets and exoplanets and the habitable zones, and how would you like to do something like that? And then somehow Kara got involved as well, Kara G, and I said, hell yeah, let's do it. I love talking science. I love educating people. I think it's kind of cool if it's going to be, you know, get a little bit of production value behind it, and we can actually have some fun with it.
Excellent.
Yeah,
well, go ahead. I'm sorry, Robert.
Yeah, I'm just going to jump in. Yeah, we work with a lot of NASA missions at IPAC Caltech, the science center that Don and I work at. And one of the projects we're involved with is something called Universe of Learning, which is basically NASA's great observatories, the Spitzer Space Telescope, Hubble Space Telescope, Chandra X-ray Observatory, the JPL Exoplanet Program. Collectively, we are responsible for doing education outreach for NASA astrophysics. And one of the things that we do in that project is create videos, hopefully working with celebrities who are kind of excited about and enjoy science, to tell different aspects of the science story. And so the Habitable Zone is the newest one that we've started doing. We have the first episode out now. We're actually working post on the second one. We're a little slower to get these out than, say, you know, the Expanse people are. You guys grind through episodes a little faster than we do. But the purpose of the Habitable Zone series was to play around with the idea of what it takes to make a planet habitable, which turns out to be a lot more complicated than just being in the right spot in the solar system, right? There are a lot of things. And so the idea was we're doing a little series of sci-fi vignettes, and each one looking at a different aspect of what it takes to make a world not just in the habitable zone, but actually potentially habitable by humans. And using that as an opportunity to really talk about the larger science of what goes on in exoplanets. And then that's kind of the connection to Dawn, because as the deputy director of the NASA Exoplanet Science Archive at IPAC, her group was actually one of our primary go-to groups for getting science feedback, because what we develop for Habitable Zone, we do with direct feedback from exoplanet researchers to make sure that we're targeting, you know, important ideas and making sure that we get the science right in what I'm doing, because I am an astrophysicist, but exoplanets are not my area of specialty. And so it's always important to go straight to the source of authority when we do things like that.
Excellent. And I guess I need to pop Dawn. Let me get these pictures off of here and put Dawn back up on screen, since you directly
bring Dawn back.
Hey, Dawn.
Hi there.
Okay, let me go ahead and answer a question I see in the comments section. Yes, the name under the doctor here, of course, is not her. It is the computer that she's using. So that's why it is Maya's name up there, which I missed totally. I shouldn't have shown that, but it is Dr. Gelino. Dr. Gelino, can you tell us a little bit about your involvement with this, the Habitable Zone, and with Cas and Robert, the whole 9 yards?
Well, so as Robert said, I work at IPAC, and so the IPAC visualization team does come and talk to us about exoplanets and things like habitable zones to make sure that they're getting the animations and the visualizations scientifically correct. I have a confession to make. I'm really busy. I've got 2 kids and a very busy full-time job, and so I don't get a lot of time to watch TV. However, I did find The Expanse recently and start watching it, and I'm only partway through season 1, but I'm already a fan.
God bless you, child.
So thank you. Excuse me. And I was really struck by the fact that this show, I think more than any other, and I love sci-fi, so this show more than any other sci-fi show or movie that I've seen really does treat the science correctly, and it's really great. So like Robert said, I was really happy to see the ship flip and burn the other way in order to slow down, so get into orbit around the stars. So I've actually, this is the first time I've ever met Cas. So hi, how are you? Good morning or evening. Very where nice you are. Very nice to meet you too. So so that's my involvement or lack
personally,
thereof.
I don't actually trust anyone who doesn't like science fiction.
Right.
That's just a personal philosophy of mine. If you don't like science fiction, then there's something sideways about you. So
I completely agree. So yeah, we're definitely on the same page with that one.
I agree. I do believe it's science fiction, which is basically running this world. I mean, just flip phones alone. I said the word flip phone. Mobile phones alone basically came off the idea of Star Trek and things of that nature. And yes, there's a lot of science fact up there. Rick, I'm going to pop you up in the room a little bit if you have some questions to ask. I'm gonna pop myself down. But
where'd he go?
Can't hear him now.
Can you hear me?
You popped yourself completely out of the picture.
Yeah, he put Rick in.
And the audio.
Oh, and one by one.
There you go. Well, I only have 4 spots. So with 5 of us that's here right now, I basically have to make a decision. So I dropped Robert down for a little bit. Okay. Robert, if you have to go to the bathroom, this is probably the time to do it. But Rick Sternbach here is basically been associated with the Star Trek series from Next Generation to Deep Space Nine for years. He's been a visualist for the show as well. But he is a huge The Expanse fan. So I wanted to give him a chance to come up here and say your 2 cents. Go ahead, Rick. You're on, brother.
Well, I first met Cas a couple of years ago at the LostCon science fiction convention, so we got to hang out together at the autograph table for a little bit.
That's right.
I hadn't seen The Expanse yet, and when I finally did, it's like, holy cow, this is just amazing stuff. Now, I mean, Mark mentions that I have worked on Star Trek. Okay, that's only half of me. Okay.
Yes. I agree.
The other half is into hard science and astronomical art. Okay, some of the first, paintings that I did were for Astronomy Magazine, and Sky and Telescope, and a little show called Cosmos.
Nice.
Okay, the original series.
It's like royalty. That's like space royalty right there.
Yeah. Well, I was very fortunate to have run into a number of other astronomical artists, and John Romberg, who had worked with Carl Sagan on a number of projects. John recommended me to Carl, and when we all got together in the late 70s, okay, it was just an astounding time because if you folks remember Voyager 1 and 2, okay, we were working on Cosmos, the series at KCET in Los Angeles, and we were also pretty much living at the Von Karman Auditorium at JPL. So we got to hang out with people like Larry Soderblom and Rich Terrell and Torrance Johnson gave me pointers on how to paint Io and things like that. So, Trek is the, the future SF part of me, but the part that really just latched onto The Expanse was all of the hard science, you know, mixed in with a little science fiction, you know, mysterioso stuff. And I won't spoil the show for.
Yeah, don't you dare.
I won't spoil the show, but there's some very interesting takes on you know, what is out there. I have a question for Cass. Okay.
Yeah.
And you know, it's a production thing. How tall is the Rosinante set? Because it looks like you guys are climbing 3 or 4 levels.
Yeah. I mean, every single area of the Rosinante is a fully realized set.
Yeah.
We have an ops deck, then we have the flight deck up above, and those two are connected. And then down below there is a galley, then there's bedroom quarters, then there's a gym, then we have an engineering room, we got a workshop space, we got an airlock, we got an armory, and every single one of those spaces has been fully built out and realized. In season 1, it was all actually attached together. Everything was attached together, so you could literally take a camera and start up in my pilot seat, and then go down to the ops deck, and then go down to the armory, and then go down to the airlock, and just in one take, you could see the entire guts of the ship. But then when we moved studios, the studio wasn't big enough, so we had to split it up. And now we got to have the wings.
You know, you guys were climbing ladders.
Oh, yeah.
Yeah.
Lots of fun. I kind of cheated. I started sliding down them.
Right.
Whenever we had gravity, I'd slide down them. And
very cool. Very cool.
Looked at me funny.
If I can make point right now, we're getting a heck of a lot of comments in the comments section that I can't put them all up. What I'm looking for are questions. So if you guys have any questions that you'd like to post to any of our guests, please do so right now so we can get that in. We're only on for about another 45 or less than 45 minutes. So you might want to get those questions in.
What they say? What they saying? What are these comments?
Oh my God, one is too long. Okay, I'm gonna put this up and see if it even fits.
Let's see these things.
Yeah, this says, and I'll read it out for those that are audible right now.
Expanse fans are the wildest, craziest fans. That's why I'm asking, because I have all sorts of different fans. I've got Strain fans, I've got Assassin's Creed fans, I got Lost fans. But Expanse fans are the most intense and intellectual and surreal. They ask questions that just blow my mind.
Yes,
So,
and
Because they're smart.
Because they're smart. And in my career, working with Star Trek celebrities as well, yes, we do get questions that are over the top, not necessarily in a bad way, but the fact that the celebrities themselves are unable to answer them because they are so technical and science oriented. And Rick knows this. You know, exactly how fast does the Enterprise go, and what's that in relevant to light speed? I'm like, what?
Whoa.
Anyway, Etta says, I think this is one of the best uses of the internet ever, combining interesting and important science with current artistic work on television, which is bringing these concepts to the general community. Great idea. I am a microbiologist, cell biologist, and my brother is an astronomer, and both sci-fi geeks since childhood. So really looking forward to season 4. Holy crap.
I got it, man.
Oh, good for you. Wow.
Bring it on.
So like I said before, you guys got questions? Let's go ahead and blow some minds here, like Dennis says right here. Amanda says, we love all the passion that Cass has for the show and the love he has for the fans. She said there's some behind the scenes for lighting and other effects available if you dig for them, but I love a full on one too. Okay. I don't know if we, okay. Dr. Dawn, I'm going to go ahead and get to you. And Rick, I'm going to pop you down so I can get Robert back up here for a sec. So stand by with me. Robert, as soon as I kick Rick out, I'm popping you back up there. Let me ask you a question that I'm sure a lot of people have probably have already asked, but I'm going to ask. This is the first time meeting you, which is such a pleasure. Is things that I love when science fact hits science fiction. So looking backwards towards science fiction, are you in fact sure? I was going to say confident, but no, I'm going to say sure that there are habitable worlds out there that are similar to our own And how do you know this for sure, lady?
So, first of all, am I sure? I will say yes. I am sure that there are habitable worlds out there. Because, and the reason why I say that is because this universe is huge. There are, there are more stars in our galaxy than there are grains of sand on all the beaches of our Earth. And so that's a lot. Yeah. And from the research that we've done so far, we figured out that on average, there's about one planet per star out there. And so we think there are, at least in our galaxy, there are probably like 400 billion planets in our galaxy alone. And so, the possibility that we are the only intelligent life in the universe is it just doesn't make sense to me. So I'm pretty sure that there is other life out there. There are other habitable worlds, and that at least one of those worlds has evolved to have intelligent life on it. Now, having said that, we haven't, so it's a gut feeling based on the statistics of the research we've done so far. And so we are finding all sorts of strange things out there. When we do find life, which, I don't know when that will be, so don't ask that question. I have no idea. But when we do find life, will it look like us? We have no idea. Will it, we'll probably find some little microbe or something first, but, we don't know what it's going to be like. But we're starting the search for life with the search for liquid water, because everything on Earth needs liquid water. And that ties into the habitable zone, right? So if the planet is too close to its star, then any water that could be on it would boil away. If the planet is too far away from its star, then any water that could be on it would be frozen solid. And so the planet needs to be just right, kind of like Goldilocks and Three Bears. The planet needs to be just the right distance for its atmosphere to be able to support water in a liquid state. And then maybe we can find life that's like life that we know here on Earth. So,
yeah,
now, I have a question.
Oh yeah,
yeah.
Because you hear this all the time in different forums and science fiction and that. How feasible, and even in season 4 of The Expanse, we talk about because it's been discussed already, so I'm okay to talk.
Well, what's that, Cas? What's that, Cas?
Spoiler.
What was discussed
It's already been discussed by the all powerful Amazon. And they put it out already, so I can say that there is a terrestrial body that we visit in season 4 called Illis. And some of the stuff that gets discussed in season 4 is the different types of life forms that could be discovered on different planets, that not everything has to be carbon based, that it is feasible to have silicon based or other based life forms. So is that a legitimate reality? Can we have life based on another atom other than carbon? And if so, would we need liquid water in order to sustain that life?
So those are all really great questions. So we look for carbon-based life because that's what we know. I don't think it's out of the realm of possibility to have something like silicon-based life. I don't know what it would look like. I'm not sure that we know what it would look like.
Well, it would look like a Horda. It would be a Horda, and it would eat through walls.
Yeah.
Sure, right.
No kill eye. We
got it.
No kill eye.
And would it need liquid water? I don't know. Maybe it would need, I don't know, liquid something else, liquid methane or liquid silicon or something. So I don't know. I don't think we really know the answer to that question.
It's really hard to rule anything out, in the sense that history of science is littered with people who have just simply ruled things out because it didn't make logical sense that later got overturned. Now, it doesn't mean that every speculation is true. For instance, with silicon, I remember as a kid growing up and seeing the Horda and getting so excited. I looked on the periodic table and I saw, oh yeah, when you look under carbon, Silicon is the next thing down, so it has similar chemistry. But for instance, there are actually good reasons that silicon might not be so great for it, because carbon bonds are stronger than silicon bonds. So carbon molecules and multi-chain molecules are actually like more robust. And likewise, silicon compounds actually need to be at higher temperatures before they can be fluid, right? Think of two equivalent molecules. You have carbon dioxide, which is a gas at room temperature. Silicon dioxide is a glass at room temperature. In order to have anything equivalent to that exchange, right, you suddenly are working with higher temperatures. It might tend to break molecules apart. But yeah, right, who can say? But the reason we look for carbon-based biosignatures is because those are at least ones we understand, right? The problem for looking for life not as we know it is we also don't know what to look for. And so, we start with what we can identify and what we can explain, right. And then but I think the exciting thing is, right, if we go and when we get to a point where we can start studying the atmospheres of exoplanets, which is something like this picture that's up right now, the idea of when a planet passes in front of a star, even though we might not be able to see that planet directly, the light from the star actually can get filtered through the atmosphere of the planet. And if we have a sufficiently sensitive telescope to make these observations, and the James Webb Space Telescope will enable some of this coming up in the relatively near future, you can look at different wavelengths of light and see how that atmosphere absorbs more or less of the light from the star, and you can start to do some of the chemistry in the atmosphere. So, for instance, if we look at a star, look at a planet that's, say, about the size of the Earth, and we see hints of oxygen in the atmosphere, that could be a biosignature, because we know oxygen in Earth atmosphere is related to biological activity. There are other ways you can do it too, that it's not necessarily going to prove life either. But the other thing is, right, we might find really interesting combinations of chemistries that we didn't expect to find in atmospheres. And those can lead us down whole other scientific paths of reasoning, once we have that kind of data in hand.
Mm-hmm.
Cool.
Yeah, that's right.
Okay. So you're basically telling me to be patient. Let's find carbon-based planets first, and then we'll go and explore looking for aliens.
Yeah,
and keep building cool telescopes that let us do this.
Yeah, that's right. I think the problem is would we be able to recognize a different form of life other than our own? And I don't know that we would at this point.
Fair.
But but we need the technology.
Star Trek episode. The whole thing was they didn't get that was like those little silicon nodules. They didn't get they were eggs. They thought they were minerals. It's that was very much about the very prophetic about the difficulty of recognizing life as you don't know it is life.
There you get a little bit of season 4 spoilerisms there, just so you know. That's a little bit the discussion that takes place in season 4.
Cool.
Different types of life forms and different things because of what we encounter on this planet.
I think in all respect here to everyone who's mentioned here, I think it's only fair, since a lot of us who are science fiction fans, it gave us a level of believability that we in fact probably didn't comprise ourselves in our own brains. So who are we to say that it's impossible for anything like that to actually exist when we only know of our own existence? Well, I should write that down. That was brilliant. Did you get that? The questions here are unbelievable, guys, and
fire away.
I don't even know what to do here. One of the interesting things, Titan has liquid methane oceans. We need another lander on Titan.
We need more money.
Sailboat. We need a Titan sailboat.
Yeah, that'd be cool.
Okay. Michael says, what about the Fermi paradox? Can anyone explain that?
Yeah, the Fermi paradox was basically an argument on why there might not be other intelligent life in the galaxy. And it basically is based on the premise that that looks at colonizing other planets as an engineering problem that's solvable. And that if even if you build ships that are relatively slow compared to the speed of light, given enough time, you would still in principle be able to get ships out to nearby planets that could colonize and build more and send it out. And if you run the numbers and make the assumption that is technically feasible at all, you get to this point that the first civilization that would pop up would probably overrun the galaxy in millions of years or hundreds of millions of years. But the galaxy itself is many billions of years old. So the idea that in a relatively short time, in cosmic time, a civilization would probably colonize everything right up front. And so if there were other aliens out there, why aren't they already here now is kind of what the Fermi paradox is.
We're number one.
That is one answer. That is actually one valid answer. We're the first.
We're number one.
And
we started.
It's also a
there are
really
other
big
answers.
place out there.
I'm sorry, Dr.
Oh, sorry.
Delaney?
It's also. I'm sorry for talking over.
That's okay.
It's also a really big place out there. It takes a long time to get to, even for us to get to Mars. Realistically, not on the show, but
Yeah.
It takes a long time. So maybe they are out there and they just haven't gotten here yet.
Yeah, if Cas
And
would
it is-
just go ahead.
It is a very optimistic engineering issue that says that, oh yeah, well, of course we'll just be able to colonize nearby systems in another 1,000 years. Physics still has limits. We like to think it's open-ended and endless, but maybe there really isn't a way of doing that pragmatically, right? We're very far away from doing it now, and there may be simply basic physics that prevents that from happening. So there could be civilizations that just don't get to go out and colonize. So
Okay, I'm going to rifle through here. Amanda says, what's the favorite exoplanet design that you guys have created for the Expanse so far? How many of the designs have been based on actual planetary bodies? Anybody?
For the Expanse.
Yeah, Cas, go ahead.
Everything
Spoilers.
in the first 3 seasons has been based on actual planetary bodies.
Wow.
Everything that our people have put together is based on intrasolar system bodies. We have Ceres, an asteroid. Ceres, an asteroid. We have Eros. We have Ganymede. We have Titan. We have Deimos, the moon around
Phoebe.
Phoebe. All these things exist.
Not anymore, but
Yeah. But
Excellent.
everything existed in our solar system, and our writers just appropriated it and used it and turned it into a story point.
And this is what turned me on to the Expanse, because I've been watching science fiction my entire life, and to get as close to believability probably started with Battlestar Galactica for me, because you're literally looking at ships that are operating in space and all of the pros and cons about that, and then you get forward on that and you go to the Expanse and you're basically watching things. I was really interested in nuclear weapons that were flying through space and headed for people to destroy them and things of that nature. I'm like, wait a minute, where are the phaser beams? Where are the photon torpedoes? I should throw Rick up here on that just to get him the answer. But it's like, this is too real, and I just happen to love it.
And you're looking, and it's all being fired by flying skyscrapers.
Yes. Yes.
We don't have all these sexy aerodynamic, beautifully sculpted birds of prey and crazy shapes, because there's no aerodynamics necessary in space. So the most efficient shape is a big rectangular block with an engine strap.
It's funny if when you look at the history of sci-fi spaceships, right, and you go back to the earliest movies like Rocket Ship XM or First Spaceship on Venus, right? They were all built as towers, right? They were built like rockets, like something that we understood.
Yes.
And then there was the switch to switching from rockets to flying saucers, like Forbidden Planet, where all of a sudden artificial gravity was created. And then certainly by the time you get to Star Trek, it's all about artificial gravity. And at that point, starship design shifted from towers and rockets to cruise ships, and that has permeated all sci-fi ever since then. Star destroyers or giant cruise ships, Star Trek ships, or almost every franchise. And it took the Expanse to come back to giving us towers again, like the way we would actually build them if we were using basic physics, acceleration, to provide our sense of gravity, right? That's the way you would do it. So it was funny when we were designing the production for the Habitable Zone series, to tell our exoplanet science story. One of the things I actually did was I went through one of the archives that you could buy CG models to see if we could save a little production time and just buy something off the shelf. And the problem is everything out there that everyone has ever designed looks like a cruise ship and requires artificial gravity. And one of our rules for the Habitable Zone series is we could not do anything that was scientifically more stupid than The Expanse does, because that would just be embarrassing if NASA was financing, outreach, and we did stuff that was less scientifically accurate. So that's one of the reasons, I actually had to build a model myself, like from the ground up, because there is nothing out there other than like the Expanse ships.
Hey, wait a minute, Dr. Hurd. Now, don't knock a Borg cube, okay? That's not aerodynamic either. It's just a freaking box and flying through space, to tell me how that's
it might
working.
be a tower layout inside. I really don't know what the layout is inside, so yeah.
That's incredible. Rick, I'm going to pull you back up here in a sec, but we're trying to rifle through these questions. I can't even pronounce that. What is your opinion of, help me on that, somebody.
I don't see it.
I'm not seeing it.
What is your opinion of Oamawu, Mau? You know what we're talking about, Don?
Oumuamua.
What I said, right? That's what I said. Okay, all right. So, what is your opinion on that?
What the hell?
I don't know.
Okay, so it's this kind of cigar-shaped rock that came through the solar system a year or so ago.
Yes, I know what you're talking about.
Yeah,
yes.
And so there have been reports that maybe it's a solar sail and it's actually aliens coming, to check us out. My opinion, it's not. It's really not. It's a rock that came from outside the solar system and was caught by the gravity of our solar system and came through. And that's that's, in my opinion, that's what it is. I don't know, Robert, what do you think?
Yeah, it's one of these situations where whenever something a little weird happens, there's invariably one person with a PhD who is more than willing to get a little attention by saying, hey, it could be aliens. And typically, that's not the simplest answer for things. It never is the simplest answer. As Sagan said, extraordinary claims require extraordinary evidence, not just, oh, it's one of 6 things I could think of that explains what's going on. And I think the particularly interesting thing about Oumuamua, other than that, it was a very long, skinny shape, which is kind of cool, was the idea that its course actually changed a little bit during its pass through the solar system based on your observations.
I knew it.
For me, I was thinking Rendezvous with Rama by Arthur C. Clarke, because, a cigar-shaped thing flies through, changes course as it swings around the sun, but, it's almost the right side, not a little smaller, but anyway. But the trick is there are other explanations on if it's a cometary body that actually has gases embedded in it. There's this effect that you get where the side that's presenting to the sun is more likely to have outgassing from it that gives you a little bit of propulsion. And so you can actually have non-artificial objects change their course due to interactions with solar radiation, and even the asteroids zip around. They radiate around. But I have to say something. I'm very proud. The Spitzer Space Telescope here was actually one of the telescopes that actually made an observation of Oumuamua, and it actually did not detect Oumuamua. But I'd like to make a statement for how important it is sometimes to not detect something, because by not detecting it in infrared light, we were actually able to more or less drive a nail in the coffin of the light sail hypothesis, because as I understand it, basically it should have, if it were a light sail, it should more or less reflect in all wavelengths pretty evenly, and it should have been bright enough for Spitzer to detect. By not detecting it, it actually became inconsistent with the idea that it's a big reflective sail reflecting at all wavelengths. So sometimes you get incredibly useful results by not actually measuring something directly, by being too faint to measure. And so I'm really proud that Spitzer largely ruled out the aliens hypothesis for that one.
Yeah, yay, Spitzer. I still think it was aliens. Okay, where's that question someone asked? I think it's this one. This is going to go to you, Cas. Love the show. Love the show. Any thoughts about how fast the ships on Expanse go? I know it's not warp speed, but in miles per hour. Speed is addressed by GS, but
they don't measure speed in kilometers an hour. They usually measure it in G forces. I'm assuming if my science is correct that 1G is 10 meters per second squared. I don't know the math that would take place to, like, if you're traveling at 1G consistently, it means you're accelerating constantly at 1G. So after an hour, where are we at? If we're starting from zero, how fast are we going after an hour?
I actually calculated that because I was kind of curious about that for the Habitable Zone video too, because again, we were using that same idea that, you know, once we get to a system, we accelerate at 1G, and I wanted to understand how much time does it take to get around. And I don't know the exact numbers off the top of my head, but I figured out that if you basically accelerate halfway at 1G, then flip around and decelerate at 1G halfway, that to get to the moon, it would be a matter of hours. And then to get to Mars, it would be a matter of days. And to get to like the outer solar system, it's, you know, a matter of weeks. So it actually is very much the time scale that we see in the Expanse. I mean, I guess in the Expanse things tend to go at like 1/3 G for, but yeah, it definitely, I mean, you think the way we go to Mars now, for instance, we send spaceships there, we give them a big kick when they launch from Earth, and then we let them coast when we're making our closest approach. And it still takes about 6 months to make the transit. That's not because it takes 6 months to get there. It takes 6 months to get there if you are basically coasting the whole time.
Understood.
And you don't want to carry like a lot of fuel.
Right. Okay. We got the science fact answer. I'm going to go to the science fiction answer right now. Hey, Rick, exactly how fast did the Enterprise go? Give us numbers, dude. Numbers.
Well, you know, for the next generation tech manual, Mike Okuda and I came up with. Well, I mean, Mike essentially worked this all out as a warp factor chart. Okay, and I don't have the numbers in my head, but you know, warp 1 is essentially the speed of light. Warp 2 is what is it? 10 to the warp factor, and I you know, I'll have to go back and look at the chart, but you know, it's a series of exponential jumps in velocity. And when we were starting Next Generation, you know, we built upon what they had done in the original TV show with, okay, warp engine and warp nacelles and coils and all of this. So Mike and I kind of sat down and we tried to figure out, okay, what are the warp coils doing to the continuum? All right, and the best way that I could explain it to the producers, okay, was it's like your car. Okay, you've got the engine, you know, burning fuel. It sends this force down the drive shaft to the tires, and the tires are actually like the warp coils, right? And the road is the continuum. So, you know, you put some force into those tires, or the, you know, the warp coils that are humming with hand waving radiation and force, and you know, however much force you put onto those tires grips the road. And in the case of Star Trek, the warp coils are gripping the continuum, okay, and pulling the ship forward and that sort of thing. So that was the easiest way that we could explain that, okay. Now I was teasing Mark in a chat a couple of days back. How, you know, could you figure out the specific impulse of the Epstein drive based on the kind of fuel that it's burning? And it's like, you know, the space shuttle had a specific impulse of around what, 360 or 400. And that's a number that means how many pounds of thrust can you get out of a pound of fuel for 1 second? All right, with the Epstein drive, you're getting a bazillion pounds of thrust from like a teaspoon of fuel. But what I love about the science fiction aspects of the Epstein drive is that it's internally consistent. Okay, we don't know exactly how it works, and I'll have to go back and I'll have to actually read the novels to see what's in there. But the fact that you can like tank up at, you know, like Tycho Station, and then just burn all the way around the solar system, you know, I think is astounding.
The way they visualize it, represent it is they're fuel pellets. They're pellets,
Right.
fuel that get dropped into a chamber. They get hit by lasers. It starts a fusion reaction, and then the ship then draws all its power from that little mini sun that it's created.
And that's actually what you've just described is exactly how, like at Lawrence Livermore National Laboratories, that's how they ignite fusion under controlled circumstances. They have this big array of lasers that fire on fuel pellets. So it's, basing it on science engineering we have today.
Yeah.
Right.
Okay.
But, even if you take
those crazy guys that are James S.A. Corey, they're always covering their butts.
I mean, but even if you take, deuterium pellets, the way they're playing with now, okay, and if you spike it with a little bit of antimatter, which they can make a little bit of antimatter, but not a lot, and you still can't get what the Epstein drive gives us.
Wait.
It's something to look forward to.
Did you just say we have antimatter?
No. I'm not saying that the expanse has antimatter.
No, I mean the Earth, a planet, our universe. We have antimatter in existence in our.
We make it.
Little bits and pieces.
Tiny amounts.
Damn.
When it disappears.
Actually, one of the biggest mysteries in physics is why the universe is half antimatter and half matter, because a lot of the physics equations implies everything should be more or less uniform. And the idea of why is there an asymmetry? Why was there more matter than antimatter is one of those things the particle physicists have to like worry about on trying to do grand unified theories. But
yeah, on Trek, I got some schooling in matter antimatter propulsion from a guy, Dr. Steve Howe, who for a long time was at Los Alamos Labs. Okay, and Steve taught me all about matter antimatter reactions. How much matter would you need on the ship? How much antimatter? And the amount of antimatter is just, it's way outside anything we can attempt today. But okay, 200 years, 300 years up, who knows?
Okay, guys, we got about 10 minutes left. Rick, I'm going to drop you because I have a question for Dr. Don coming in. That was a great discussion. I wonder if you put a bunch of geeks in one room, and if you put a bunch of scientists in the other room, who would be the last man standing? That's what I'm wondering. Okay, Dr. Gelino, got a question for you. What is your favorite exoplanet? Or planets. Let's go plural here. Planets.
Oh, yeah. No, there are so many. So we know of almost 4,000 planets.
Give us five.
Give you five.
Give us five.
They all have Kepler and a number after them. So,
not my favorite.
What's that?
Not my favorite. But go ahead.
Not your, well, there are a whole bunch. So we have found all sorts of different types of planets, right? So there are a number that are like our Earth. We know of about 120, 130 of them that are in their habitable zones the entire time that they're orbiting their star, but I think actually my favorite planets are the ones that are strange, right? So we've found a lot, but we found a lot that we've never seen in our galaxy, in our solar system. And so like we have these really big, hot Jupiter-sized planets that are really, really close to their star. And so they're whipping around their stars like once every couple of days. And for something that big to be going around their star and such a small orbit, it's like if we lived on those planets, well, if they were rocky planets and we could live there, then we'd be like 1 million years old because a year is only 2 days. So it's kind of good that we don't live there. But there are also planets that are so dense, right? So they're about the same size as the Earth, but they have they're much more massive than the Earth. And so 55 Cancri E, I guess, is one of my favorites because it has, I'll get to TRAPPIST-1 in a minute. That's what you're showing now. But 50 Cancri E is so dense that the carbon in it we think could be compressed to become diamonds. And so it could be a complete diamond planet. Maybe not complete,
wow.
but you'd have a really high density of diamonds in the planet. And so that's pretty cool. It also is, so you showed one of the slides here, was TRAPPIST-1, the TRAPPIST-1 system. There's 7 planets there. 5 of them are Earth-sized. 2 of them are even smaller than Earth, but they're all rocky, which is great, but they're all orbiting what's called an M star. So a star that's about 10 times smaller than our sun. And so the habitable zone, all stars have habitable zones, but the habitable zone for this star is much smaller than the habitable zone for our own sun. So even though the innermost planet is orbiting at about like a day and a half, and the outermost planet in the TRAPPIST-1 system takes about 20 days to go around the star, which is still super fast. There are 3 to 4 of the planets that are in between those two that are in the star's habitable zone. And so that's really, really cool. We think that a few of them may have water on, as part of their.
Well, Tara and I visited a few of them.
Yes, I did see it.
And we evaluated their ability to sustain life. It's not easy.
It's not easy. No, it's definitely not. With M stars, you get a lot of M stars are very active, so you get a lot of flares as well. So maybe one big UV flare could fry everything on the planet. We don't know yet.
Right.
So.
Well, spoiler alert here for anyone that hasn't completed season 3. Okay, spoiler alert, fair warning right now. End of last episode, season 3, episode 13, I think it was. We find our crew heading in various directions. Dr. Jelena, if you were on one of those ships and you would have to go through one of those, what were we calling them, Cas? Ring gates. Ring gates. Okay. If you had to go through one of those ring gates, in which direction would you recommend that crew to go?
Oh, goodness. I don't really have a good answer for that because, so we've only really looked at a quarter of 1% of the sky. Like that's it that scientists have been able to look at so far. And so I guess if I was assured that I wouldn't come out of the ring gate like in the middle of a star or in some like asteroid field where we'd get pummeled right away, I guess I would say that to go through one of them that is in a completely different direction than the one part of the sky that we've already looked at and explored, right?
Oh, so you're basically saying just swerve to the left. Swerve to the left.
Yeah, kind of. Or the right, whatever you want.
Roll the dice.
All right, very
hit
interesting.
That button right in the Habitable Zone video. You're just hitting the button
Throw
and it's
a dart.
Yep.
Throw a space dart.
Right, throw a space dart, exactly.
All right, we're down to about, let me bring Robert back up here for a minute, and we're down to our last 7 minutes here, guys. So there are so many questions here. Just letting you know that I think what will happen is any of the doctors and Cas can access the Facebook page where this program is broadcasting, and they can at some point tap into those messages or those questions, shall I say, and answer them on their own if they feel to do so. But there are questions here that there's no way we're going to be able to get to them, but we are trying our best. Let me go ahead and somebody made a good comment about something I just said. It's a second ring gate to the right and straight on until morning. Yes, I agree. Cas, I have started the show all over, and the detail is amazing. Let's see. I'm still going through it. Okay, think about.
You're looking through those. Let me toss out one more comment I just wanted to make about why TRAPPIST-1 system is my favorite of everything we've discovered so far, and because of the habitable zone of the star being so much closer, and the fact that there are these 7 roughly Earth-sized planets, that the spacings between their orbits are more like the spacings between the orbits of the moons of Jupiter. But imagine taking them planets as big as the Earth and putting them that close together. If you were actually in that system and you looked up, if you're on one of these planets and you were looking up at the sky at your neighboring planets, they would appear as big as the moon does in our sky. Only you wouldn't be looking at your local moon, you would be looking at the next planet over. That is a system that, like, your nighttime views of the planets in your sky would be amazing. When one of the planets transited in front of the star, you know, the next planet in maybe passed from the star, it would block out like a significant fraction of the star's light, right? It wouldn't be this tiny little pinprick we see when Venus happens to transit in front of our star. It's like it's like what all the sci-fi paintings of what exoplanets were supposed to look like back in the 60s and the 50s, right? It's a system where it really looks like that. So I think that's just kind of mind-numbing to be able to be in a system where it's so close together and so
unbelievable.
It's only 40 light years away.
Yeah. Okay.
Let's
see.
40 light years.
That's not too far.
It's not that far. It's right with the Epstein drive, you might be able to get there.
Hey, look, as long as the spaceship has cable, I'll hang on for as long as it takes. That's all I need. Dennis says here, I hope this question still gets through. And Dennis, your question just got through. Since Mars has another gravity than Earth, how would that influence the evolution of man in terms of the body? Will humans be taller or smaller, etc.? How long will that take?
Cass, did you get any taller as a Martian?
Well, I think, what is it? 1/3 gravity. Mars is 1/3 of Earth.
Mm-hmm.
Yeah.
And so, I mean, I got my education from the various NASA astronauts that came and talked to us about gravity and its effects on bone density and muscle tissue. And from what I was told, the body would start to get taller. So, and your bones would get thinner. And however, us Martians, we work out like crazy. So we're trying to maintain our Earth level physique, so that, because, you know, we have two things on Mars, which is terraforming and the military, and everybody is training to bring the fight to Earth if we have to. So most of the Martians train in 1G, but if they're not training in 1G, definitely it's going to affect their bodies, and the belters are the extreme example of that. Yeah. But I would guess that you're going to be a little bit taller, a little bit weaker, a little bit more fragile, and I'm sure there's long-term effects of gravity that we don't even have any clue of in terms of biology.
Well, what were the twins who just came off the ISS and their comparable differences? Any of the doctors who could probably answer that? I think one of the twins got shorter or taller. Anyone know?
But it's really, really small. This is not something, like, you have to measure that very, very carefully, like it's settling. And the other thing that's worth noting that, and I'm no biologist, but knowing enough, right? Evolutionary processes are also much, much, much longer, multi-generational, and they only affect who reproduces under what conditions they reproduce, right? So the idea that you just naturally get children that are taller every generation, that's more of a kind of a discredited form of evolutionary understanding called epigenetics, I think, that implied that each generation just sort of naturally adopted principles that were better, and it wasn't actually grounded in what kind of genetic information actually gets passed from generation to generation.
You know what I think would affect us even more than gravity is the selection process of the colonizers, because everybody that's going into space right now is a very specific kind of genome. Like, we're not getting a random sampling of Earth's entire human population going into space. They're very specific. They're very highly scientific, highly educated, usually not physically robust. So you're limiting your gene pool by the actual selection process of who those colonizers will be. I mean, that's actually one of the things that the Expanse Mars community actually exhibits. Is our creators said who's going to end up taking the one-way ticket to Mars, and they decided it was going to be East Indians, Pakistanis, Asians, and Texans.
Yes.
Those would be the people most likely to establish a colony on another planet because of their particular cultural and physiological and intellectual and emotional compositions. They'd be the ones that would go and take that one-way ticket and be able to conquer a hostile very inhospitable terrain.
You got to at least have one guy that speaks Creole. You know, you got to take one of, yeah.
You need at least one female if you're going to procreate. So.
Yeah,
This is true.
But you're actually making the argument that the smart, weak geeks go to Mars because it's only 1/3 gravity, so being a weakling isn't a big deal there.
That's not what I said, but okay.
Hey, Kaz, I guess this is going to this one. This says gravity on Mars is about the same as in Saskatchewan.
Don't be a smartass.
Yeah, guy named Eric Briggs. I don't know if you know him or not, but
I do not know him. He's just making fun of where I'm born.
yeah, exactly. If you guys didn't know that Kaz is from, he's a Canadian. He's a Canuck.
Saskatchewan is like growing up on Pluto. It is so damn cold. You're gonna freeze your eyeballs off, and your fillings will fall out of your teeth.
Well, I think Chicago might top you on that one since they got up the temperatures that match the Arctic Circle or the Antarctica, I think.
Friend, I don't know. We have nothing but flat wheat plains and blistering Arctic cold. And
wow. Well, at least you can see a polar bear coming. That's all I can say. But, Dr. Gelino, I'm fulfilling my promise here. I know you have to go. The other guys here, if you could hang in for 5 more minutes, I'm good. But I know, Doc, you have to go.
I have another meeting, although I could probably be 5 minutes late for this.
Oh, we'll do 5 minutes.
If it's only 5 minutes, I can do that.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay. Melody says, thank you for everyone for this fun and exciting discussion. This is fantastic. That's all fine. Here's one for you. What do you think is more economically and technologically feasible, either colonizing and terraforming Mars or traveling to a possible Earth-like exoplanet? That's actually a good question.
Ooh.
Yeah.
Both are very hard. That is a really good question. Both are really hard. So we don't have the propulsion systems to get us to another Earth-like planet.
But if we did,
if we did, that would probably be easier and more economical. I mean, terraforming Mars. So Mars doesn't really have enough CO2 to be able to terraform itself. We would have to make some big changes on Mars before we could terraform it. And so I think if we had a way to get to, or if we had the technology to get to another Earth-like planet, I would say that that's probably the winner. But both are very hard, and neither will happen in our lifetimes. I'm fairly certain.
We can at least imagine a possibility of terraforming Mars. We currently cannot imagine the technology that would let us get to a nearby exoplanet.
That is true.
Speaking, from what we know in physics and engineering.
Right, but yeah, Mark said if we had the technology.
Yes, if we.
That's why I gave the answer I did.
And yes. based on what Robert said, I think it's all based on what we know. We know a lot more about Mars than we do any other exoplanet. So
that's right. In fact, what we know about the
shouldn't we be creating something on the moon first before we start venturing out? Doesn't the moon provide us with a lot of advantages? And
have you not seen what happened in space 1999, Kaz? No, absolutely not. Okay, we'll bust away from our planet like that. No, let's go to Mars or another planet. We've already proven what would happen in space 1999. Let's see.
That's a really interesting argument, because the truth is, Mars's atmosphere is so thin. It's only like 1% of Earth's atmosphere. Okay, this is not enough atmosphere to be able to just walk around with a breather mask, right? Your blood would boil, right? It's not that different than the moon from a practical standpoint. There is a little atmosphere there, but not very much. So it doesn't really gain you that much. It doesn't have a magnetic field to protect you from the solar radiation, charged particles. Neither does the moon. And the moon is a lot closer than Mars. So, in some very realistic sense, colonizing the moon isn't actually that harder than colonizing Mars. And it's the distance factor makes it a lot easier to do many things, to get back and forth. So,
did any of you hear what I just said?
Yes.
I'm sorry, Kaz. Go ahead, buddy.
No, I heard that they discovered lots of water in the form of ice crystals in the dust that now, like at one of these many science conventions that I've been blessed to start attending in the last 3 years, they were advertising technologies that were going to be microwaving the moon dust and vaporizing the water into steam, and then extracting this water straight out of the mantle of the moon. So it just sounded really like what we didn't know, all the resources that were available on the moon, and that, you know, if there's lots of water there, that's a big that's a big deal, because that's a lot of water we don't have to transport from Earth.
Yep, a lot of people are commenting based on what you guys are saying. Specifically, Teresa said, which always makes me wonder about the dust storms on Mars. I mean, what is blowing the dust around? Cas.
Very fine.
A lot of hot air out of the Mariner Valley Texans.
Oh, hold on. I saw a comment in relation to that. I don't know where the guy went, but he was basically, I don't see it, sorry, but he was pretty much proud to be from the Lone Star State. So he's canceling his Amazon subscription as we speak.
Oh no! Say it ain't so, Joe.
Yeah, there was a lot of comments so far. Moon dust is like glass shards. It was eating into all of the seals on Apollo missions. Okay, that's interesting.
Well, we know that Mars dust is fairly abrasive too, because looking at what happens to the wheels on the Mars rovers, you know, those things, even though they're only in 1/3 Earth gravity, right, those things are getting torn up just grinding through Mars dust. So that it might not be quite as bad as moon dust, but it's probably not great for you either.
Interesting. Okay, we got a lot. We're getting into a lot of colonization questions here. I think we got to try to move on.
I just wanted to draw attention, since one of the things I wanted to draw attention to these little shows that we put together, the exoplanets and the TRAPPIST system videos that we did for NASA, that Kara and I and our lovely guests have put together.
You there?
I am. I'm hearing music.
Oh yeah, that was actually my phone. I'm sorry. Yeah.
I just wanted to make sure that everybody who's listening knows that there are these 3 or 4 10-minute videos that Kara and I and the creative team at NASA put together to kind of show what it would actually be like to explore these exoplanets up close and personal in the TRAPPIST system. And I had a great time. Me and Kara had a great time doing it, shooting it. There's a little kind of flavor of our characters that we play in it, but it's really all beautiful, wonderful science that we get to explore with a little bit of tongue-in-cheek humor. So I want to make sure everyone checks that out. I don't know if you're going to have links or anything for people to.
Oh yeah, absolutely. And we were going to bring that up towards the end of the program, which we can go ahead and set now.
I'm bringing it up now.
Yes, sir. Yes, sir. Absolutely.
Right.
If you guys have not seen the Habitable Zone and anything that Kara and I understand there's an episode 2, and I know I put Robert down in the lobby so I can go ahead and pretty much show these clips. But I do believe, Robert, I can still see you, so you can nod if you can. But I understand that there is a episode 2. Dawn, if you can answer that. Cas, if you can answer that, because this is episode 1, I do believe, the Goldilocks paradox.
Oh, I think there's at least 3 or 4 of them in the final.
Yes. Right. So there's the video itself, and then there are 3 or 4 other videos that are actually Robert and another one of our colleagues, scientific colleagues, that are kind of breaking down the video and explaining it in scientific terms, but so everyone can understand. So there I am, my mouth open.
Excellent. And there are on YouTube, and if you guys do not have a link, we will provide the link. Or Colin, I know you're online and listening too. If you can go ahead and provide the link to that YouTube, address to this incredible. This was really nice to see, and it wasn't really that long. I actually was hoping for more, but it was very, very interesting to watch, and I'm really proud of everybody to put that out. The fact that you are mixing a little bit of science fact with science, or I should go science fiction with science fact, and then science fiction again. What's brilliant. I really enjoyed it. We're all happy that Cas has made himself available to do this. And
Thank you.
this was incredible. So I guess without any further ado, my God, you guys, you still have questions. I see them. I understand. I implore you to go to websites such as universeunplugged.org. Try to keep up with my Facebook page too, which is how you got to see this broadcast in the first place. And we'll try to do some future updates for you.
And if you get frustrated with how absolutely incredibly difficult it is to find a habitable planet, and how hard it would be to terraform, and how long it would take you to travel there in real life, then go check out The Expanse. Season 3 just dropped on Amazon, and you can watch all 3 seasons.
Okay, before we segue off of that, Cas, I understand. Now, okay, real quick.
Yes,
we
sir.
understand that Sci-Fi, who originally had The Expanse, okay?
Yeah.
It went for 3 seasons, and they decided to cancel you.
Right.
Jeff Bezos, who I actually know and have worked with, because Jeff Bezos actually, I emceed a convention, a Star Trek convention, 40th anniversary Star Trek convention, where Jeff was actually a guest. And he brought all his little Star Trek stuff that he grew up with for 5 years old, whatever. But beyond your wildest dreams, would you ever expect a billionaire to come to the rescue and pick up the next season of The Expanse, which we thought was the end of? Can you give us a really quick, a little bit of how that happened? How that worked?
It was an emotional roller coaster. We were all stunned, shocked. We all went through a variety of emotions. Every single one of us went through our own journey to let go of something that we loved so much. Some of us moved on immediately because that's what they needed to do emotionally. Some of us, there was some anger. My personality is, I kind of was in denial. I refused to believe that anything this good, that was getting this kind of critical acclaim and fan support, could end before it was allowed to reach its fruition. There was no reason for it other than money. And so in my mind, I just wouldn't accept it. And then I found out this information about Jeff Bezos being a big fan of the show personally, that he loved the books. And once I found out that information, I had like this little visualizing moment in my head. And in my mind, I said, because I had been invited to the ISDC event to do a panel myself on the science of the expanse. And I found out Jeff was going to be there. And this was months before. And I thought to myself, I can see him deciding to bring the show back on stage, and
Wow.
all the people being there, and
Wow.
I imagine the president of our company being up there with him. And so because of that kind of live waking dream I had, I invited all of my co-stars to come with me to the panel, because it was just supposed to be me. And I said, I'm going to make a big event out of this. And then I asked the ISDC to schedule the panel that we were supposed to do just before Jeff was going to arrive, because he was arriving to receive his award, so we could bump into each other. And it was just this organic kind of natural instinctive thing that I visualized it, and then almost everything to the letter that I had seen a month before manifested that day. And Jeff decided, he contacted Amazon while he was at dinner, texting on his phone for 15 minutes solid, and talked to the head of development and found out where the negotiations were, and got the okay to announce during dinner while we were there, and then got up on stage, and like the brilliant CEO that he is, sees an opportunity to announce a show that he loved in front of the cast, in front of the press, and in front of 1,000 scientists. He couldn't get a better audience. So he just used his very powerful noodle and said, this is the best time to do it. If we're going to do it, let's do it now.
That is absolutely incredible. The fact that I got involved late in the game with The Expanse, not during season 1, but honestly, probably mid-season 2, that I really got involved, and then I just couldn't believe what I was watching. I'm like, wow, this could actually happen. It's like, watching one of the incarnations of the Batman movies, where you're saying, whoa, I can actually be a Batman. All I need is Jeff Bezos's bucks. That's all I need. That's all I need. And boy, I'll be swinging. And I was just gobsmacked because I knew I had Jeff in Seattle with me years and years and years ago, and I knew that he was a huge Star Trek fan. I didn't know how deep his science fiction roots basically went. I guess I did, because he said at 5 years old he cut out cardboard copies of a communicator and a phase and a whole 9 yards. He actually brought it to the event to show the fans.
He was a big nerd. He was a big nerd.
He is a massive nerd, but the fact that he took it upon himself of seeing something on TV that he liked, and the fact that Sci-Fi was not going to continue it, and he said, look, I'm taking it upon myself and I'm going to make this thing keep going on, is phenomenal.
Let's not forget, like, the most important part of the equation that we haven't mentioned now. This wasn't just Jeff going on a whim. This was Jeff and Amazon responding to a massive fan outcry.
Yes.
The fans were the Nova Sun. They were the nuclear kind of explosion that caught everyone's attention. They were basically saying, we're not going out without a fight. They were so creative. They were so passionate. They did things like send banners across the headquarters of Amazon and launched a balloon with a little mini Rossi ship that went into orbit, and they videotaped it. So there are pictures of the Rossi above the Earth in the higher upper atmosphere in orbit that they paid for. And they did all these extravagant stunts to get the attention of Amazon, and Amazon, that had originally said no, reopened negotiations because of the fans. And Jeff found out about what was going on because of the fans. And then finally just everything came together that night. Amazon and Alcon, the production company, were negotiating already pretty hard. They had gotten a lot of it done, but there was still a lot of stuff still to do. And the fans, they showed up at the event. They snuck into the dinner chamber. They held up a big sign saying, "Save the show, Jeff." And Jeff just took it upon himself to say, you know what? If we're going to pull the trigger, let's do it right now. And he just made sure that nothing was going to stop the show from getting picked up. So
that is
the fans were the heart of it. The fans were the heart of it.
Well, great. Okay, season 4, and Doc, I know both Docs, I know you're still here, and even Dr. Delino, you know, if you have to leave, we'll just wave your hand at me real quick. But in getting into season 4, I know there's a lot you cannot tell us, but you already have a fan base. No one's really big into spoilers anyway, if you're a true fan. But are we looking for anything that you can kind of tell us in terms of advancement? Towards the end, the Martians, the Belters, and Earth alone looked like they were doing their kumbaya kind of thing towards the end of season 3 or whatever. In fact, season 3 ending wasn't necessarily a cliffhanger. It reminded me so much of the ending of Battlestar Galactica. But where are we going, Cas? What direction? What developments? New characters? What are we looking for that you can tell us?
Season 1, 2, and 3 really are like the first movement of an opera. This is a space opera, and as you said, it was like the end of an entire movement. And with the opening of the ring gates, season 4 becomes the second movement of the same story. But it's a brand new tone. It's a brand new energy. It's a brand new field. The first 3 seasons, we were basically just struggling to survive in our solar system. We were fighting over resources. We're desperately trying to terraform Mars. Everything. It was a desperate, frantic kind of rush for the finite resources we have in our solar system. At the end of season 3, the entire galaxy is opened up to us. 1,500 ring gates, and all the subsequent galaxies now are at our disposal. The entire playing board has changed. The equation has changed. Mars has changed because Mars is now not our only viable resource to create another colony. So we're basically starting season 4 the way the United States was during the gold rush. New territory has been carved out. There are untold wealths and riches and resources out there waiting to be discovered, unknown dangers, and it's basically a mad rush for no rules, no laws, no regulations. It's an unregulated environment. What the hell's going to happen now that we have 1,500 gates to thousands of different galaxies and, you know, hundreds of thousands of different planets? What's going to happen?
I do understand that, like you said, it's a space opera, and it can break off into different fragments. I just basically want all the main characters to stay within their, hell, I still want the Martians and Belters and Earthers to still be kicking each other's ass. At least everybody's together in the same galaxy.
Oh, well,
like
have no fear. The Earth, Mars, and the Belt are not going to be burying their hatchets that easily.
That a boy. That's what we want to hear.
Human beings, as soon as you start throwing more goodies on the table, they're always going to find a reason to fight. That's just how we're built, man.
Yes, that's what I want. I want more fighting. I love the political aspect of it too. I really do love the political aspect of it, and we need that, and not just all action. We need drama as well. And if I can point out the season 3 first episode, I think that's the one where you made your call to home, where you pretty much spoke to your wife and whatever and you were basically visually texting. Go ahead.
He manned up to the truth. He finally was honest with himself and his wife and told her how he felt about, what he was meant to do. And it was a very, very difficult epiphany for him to actually verbalize that he's happier out here behind the cockpit of his ship than he is at home.
Yeah. All right. On that ending, those that are watching us right now, you do understand you're not going to get much out of Cas in terms of season 4 unless you send him lots of money. Cas, do you have any favorite chocolates, or what's your guilty pleasure?
Chocolates, man. I'm all about dark chocolate with a little bit of spice.
Ooh.
Like those Mexican spicy dark chocolates. I love those.
Okay, guys, you just heard what your bribery, your bribe content. I'm going to go ahead and say goodbye to a lot of our guests that are online. I'll get Dr. Geleno off first. Ma'am, thank you so much. Is there anywhere that people can contact you and without invading your privacy, shall I say?
Well, I have a work email address. You can Google me.
Google
you'll find my email address, I'm sure, somewhere.
I think it's better if they came and visit your website or something to that respect. Anything that people can go to?
That's a good question. No, actually, I've been really bad about that. I mean, I have a website. IPAC is at Caltech, right? So I'm the deputy director for the NASA Exoplanet Science Institute at Caltech. So you can type in IPAC and my name will come up. I run lots of programs for NASA headquarters. I did a TED Talk a couple months ago.
Yay!
On the search for life in the universe, so you can Google that. Maybe you just Google my name, and I will try to look back and look at the questions that we weren't able to get to over the next couple days. And also, I'm a co-creator of the Habitable Zone Gallery, so it's hzgallery.org, and that's it's basically a lot of information and plots and movies of all of the planets that we know of, that we have enough information to plot their orbits and where their orbits are. Yes, thank you. In really ORG in the end.
I'm sorry.
That's okay. Org. With respect to the stars' habitable zones. And so you can check things out. You can sort on the tables. You can see, how many planets we know of are actually orbit within their habitable zones. The whole, 100% of their orbit is within the habitable zone. That was in conjunction with my colleague Stephen Kane, and
not the Stephen Kane.
The Stephen Kane. I don't know if you know who he is, but I just wanted to make one comment. So I know I said that I was only partway through season 1, but I can already see that that women play very strong characters in the show, and I'm really, really happy to see that. And today is the UN has dubbed today, the International Day of Women and Girls in Science, and so as a show that is so committed to getting the science right, I'm really, really happy. And encouraged to see that the women on the show have very strong,
Shout out to the women in
Yes.
science.
Doc, you
Yes.
have you
And
said
not just women, but women of color.
Oh, that's right. Yes,
are
across
very-
all races. It's
are
it's
very,
awesome. It's amazing.
Because we take pride in the diversity of our show across all races and gender, where the race or gender does not really play any role in where people are at in the expanse. In the past 3 seasons, we've had 8 female leads, 5 of whom were not white, and none of whom revolved around a man.
That's awesome.
They were all strong, butt-kicking, intelligent, fierce leaders in their own right, all of whom drove the plot forward. So they take great pride in the diversity, and specifically in the women and the women of color that they've put into our story.
right. And
So
Dr.
thank you for that.
Gelino, Dr. Gelino, if you've only gotten through season 1, you have no idea what you're about to experience.
I know,
and
and it's a priority.
Nothing yet, Doctor.
I know, but it's a priority.
in terms of girl power, oh my God, that's all I can say.
Awesome.
Wait
I'm looking
till
forward
you
to
get
it.
to season 2.
Awesome.
Yeah, hopefully they'll continue that empowerment during season 4. Cass.
Oh, they do.
Okay.
Avasarala in season 4. Holy crap!
Really?
Oh yeah. And Bobby is constantly on an escalating power route. But
I did an Expanse panel at Dragon Con up in Atlanta, and I had a bunch of you guys up on stage with me, and I think Bobby and I are the same height, if not taller, and I'm 6'1", 6'2".
Yeah, no, she's a tall girl. She's an Amazon.
Oh my gosh, she is definitely an Amazon. But her and Show Ray, they were just all absolutely brilliant. Show Ray, we made. Hey guys, watching right now, if you know how much profanity that's used in the Expanse, and Dr. Gelino, just letting you know, we literally on stage in an audience of thousands made sure Ray curse until there was no end.
All right.
We had to bleep her out.
Yep, it was absolutely brilliant. Okay, Dr. Gelino, I'm going to go ahead and let you go first. Thank you so much for being a part of this broadcast.
You're welcome.
And anytime you want to do this again or need to do this again, just look me up. Just contact Colin, and he'll contact me, and we'll do something special for you. If you want to do it alone, that's all well and fine. But we thank you so much, guys. A great round of applause for Dr. Don Gelino. Thank you.
Thank you for including me.
Thank you so much, and I appreciate it, and good luck at your meeting, because I know you have to run.
Thank you. Yes.
Okay, bye-bye.
Bye-bye.
All right, that's her. Let me go ahead and get Rick back up into the screen here. Sorry we excluded you, Rick. I only have four screens here.
Not a problem.
Yeah, that was fantastic. Anything you want to, just to be fair, anything you want to touch on before we go ahead and sign off with everybody as well?
Me? No, I've been having a ball just listening to everybody, tell their stories.
All righty, fantastic. Dr. Herb, I guess we're going to go ahead and sign off with you. We thank you so much for you joining this broadcast. You brought a lot to the table, a lot to talk about. You've enlightened us. Is there any place that you want people to come to see you or anything that you're involved in?
Sure. Well, I mean, I'll just plug in the Habitable Zone, and I just have to say, it was just such a pleasure and honor being able to work with Cass and Kara, shooting our little science videos. They brought so much energy to the table, and the fact that we have a very technical script with a lot of scientific techno not babble because it's actually correct. The fact that they could come in and actually just handle that stuff without choking on it is just a testimony to how well trained I guess they are on this, and how really engaged they are in the subject matter. And we have the first episode out now with the after show, like we were talking about, the Goldilocks paradox. We're actually editing, we're doing post and editing now the second episode, the Scorched Earth Enigma. And I got to say, Cass, some of the improv that you did on set is just like our favorite moments in the editing process. And they brought stuff that wasn't on the table.
You gotta have fun. You gotta have fun.
Oh, that's totally fun.
One of the constants in human behavior is no matter how stressful, no matter where you put us, human beings, no matter what they're going through, they will always find ways to find humor and levity in whatever crisis or situation they're in. That's just how we're wired. It's how we're built. We try to lighten things up to keep them in perspective. So
very true, very true. Dr. Hurt, when can we expect that second episode?
It'll probably be within a couple of months. We have to see. We got to figure out like our optimal. But the main idea is, of course, we're going to get it out long before season 4 drops. So if you can't wait until whenever that is for more of Cas and more of Kara, we'll give you a little opportunity to see them. And of course, while Cas is very similar to Alex on screen, he gets to play a pilot. He does that. This is a chance to see Kara not speaking Belter. So
yeah.
Oh, okay. Yeah, and Kara, and I forget Kara's last name, but she's on General Hospital, which I'm always at work when that comes on anyway. So we understand that she is an additional cast member in the Habitable Zone.
Kara G from The Expanse, and then Perry Shin is our third cast member. Perry is the one who's on General Hospital.
Oh, Perry as well. Kara is not.
No. Kara's drummer on Expanse. Kara G.
Kara G.
Oh, that Kara G.
She was my co-pilot in this Habitable Zone. She plays drummer.
Yes.
Right.
Yes.
And then Carrie, who is another gentleman from General Hospital. He's the Rod Serling type that does the Twilight Zone intro on each of these episodes.
They're a computer with the Rod Serling complex.
Yes, and you guys that are listening right now, you really have to go and see. How long was that? About 14 minutes, I think. How long was that episode, Doc?
No, they're just over 5 minutes.
I'm sorry. Yes.
Keep it up. And then we have like the after show segments where we talk about the exoplanet science a little more, and then there were several of those that reach around 3 minutes or so. And then the second episode, well, again, we're trying to keep these short so they don't feel like really, really long. You know, we're just trying to make them fun, and hopefully we may get a chance to do more too downstream. So we'll see what progresses. So
yeah, and I love Kara G and her portrayal as drummer. In fact, when she put on that exoskeleton, I guess I should say, to help her walk, I cracked up as soon as I saw her start walking along, and I'm like, it was the funniest thing because she was squatted down a little bit. So yeah, she's a great character, man. She is really a great character.
Fierce person, fierce actor, and an incredible character.
Yes, absolutely. Okay, Dr. Hurt, I guess we can go ahead and say goodbye to you.
Yep, and if you catch the video on YouTube, make sure to click through to get to the universeunplugged.org site, because we actually have downloadable wallpapers there. We also have fun facts that tell you about all the science in the episodes, and even links to like similar science stories. So we tried to give you the whole package there.
Excellent. Well, we thank you so much for joining us for over 90 minutes worth of information here. We can go on for days, I'm sure. So we're going to go ahead and say goodbye to you. So thank you, Robert Hurt. Really appreciate it. Talk to you soon, Doc. I'll get up with you.
See you later, Robert.
Yeah, and let's go ahead to Rick Sternbach here. Rick, it's been a pleasure, man, and we really appreciate everything that you've been involved with in Star Trek over the years. It kind of put us into a level of reality with the series that you worked on, and we've only gravitated up to Cas's level right now in The Expanse. So thank you so much, my friend.
Hey, you had a great time. Thanks a lot.
All right, and I'll talk to you soon, Rick, okay?
Great to talk to you again, brother.
Yeah. All righty. Bye-bye. And, of course, the man of the hour here, what can I say? This guy has just basically been the ringleader, the party goer, the guy that, I will put you pretty much stand responsible for getting The Expanse on. And I know you're in Germany right now, so
I am.
Yeah,
I'm in Berlin.
In Berlin, and you are 6 hours ahead of my time, East Coast time right now, and 9 hours away from everyone else who is joining us here online. So we really appreciate you joining us. I've been trying to get a hold of you.
Been promoting the heck out of my new film, The Operative, which just
Tell us more. Tell us more.
It just premiered last night, starring Diane Kruger and Martin Freeman, one of my favorite actors out there.
Hobbit.
The Watson from Sherlock and The Hobbit.
Yes.
And Fargo, and I think he was Arthur Dent from Hitchhiker's Guide to the Galaxy.
Yes, he was.
He has quite the portfolio, this man.
What is the premise of your movie?
It's a spy movie, a very different kind of spy movie. It's a spy movie. Diane Kruger plays a spy working for the Mossad that has to infiltrate Iran and do some very dangerous and difficult missions. And it's all based on true stories. And during the course of her mission, she meets my character, who's an Iranian electronics engineer, and she's supposed to just use him and exploit him and get him to help her accomplish her mission, but they end up falling in love. So it complicates the entire mission, and his life gets changed forever, and she has to go through this very dangerous situation of extracting herself out of this complicated web. And what it really is a spy movie that deals with not so much the car chases and the gunfights, but more the human cost of being a spy. It's a very realistic portrayal of what goes on in the minds of a spy.
Yes, you consider it a psychological thriller.
A psychological thriller, and the cost on the people that are in this life, and the cost of the innocent people that get dragged in against their will into these situations. And that's something that we don't really get to see that much in a story form. It's always about the action, and this is more about the people.
And when do you expect it to debut here in the States?
That's a good question. I know they're going to start distributing it here and overseas probably in the next few months. So hopefully by the end of the year.
Okay, and what's the name of the movie again, please?
The Operative. Yuval Adler's writer-director. It's his baby, and it stars Diane Kruger and Martin Freeman and myself.
Okay, just want to make sure that we push that. And of course, all you guys out there who have been watching and supporting Cas as much as you can do, as much as you have, please go ahead, and you screaming Firehawks, please go ahead and spread the word around about
Bring it on.
Cas's new film, so we can go ahead and buy a ticket. But hey, thank you so much for joining us. I really, really appreciate it. I know you might want to go get some dinner and probably hit the hay.
Rest
I know
time.
you're exhausted, but thank you so much for joining us. If it's anything you need from any of us, just go ahead and holler, and we'll go ahead and Colin. Let me talk about Colin real quick. Colin has been incredible. Colin Pelton, who basically is your social media
He's the man.
manager. He is the man, spreading the word, putting all this together with me. He is very, very supportive of you, supportive of the show. And he's actually a pretty incredible individual. So my hat's off and my applause to Colin.
Him and his company, Collaborative Entity, were a huge part of saving the Expanse. They were kind of my ninjas in the shadow. They ran my account. They ran a bunch of accounts. They helped me when the big stuff happened, and I had to broadcast everything on three different platforms. And
you just turned sideways.
what
but that's okay. Keep talking. Yeah. Oh, lost you. That's okay. Colin will probably pop back in just to say bye. But everyone that's been oh, there you go. I see you. Hold on. He's in the lobby. Let me pull him up to the studio here.
Okay.
And there you go. We got you.
But yeah, Colin and Collaborative Entity were big parts of the Save the Expanse campaign, and they've been a part of the show with the live tweeting and everything like that ever since the beginning of the show. And he loves the show. So he helped put this whole thing together today. So I give a big thank you to Colin and Collaborative Entity for all their hard work over the years and in the future.
Well, that's great that you have a continuing group of fandoms. It's the fans that make, let's say, corporate America or the film industry make them look up and notice. Don't want to say anything negative about sci-fi, but I think they really lost something when they decided they didn't want to renew The Expanse. But at least with groups like you have here, Colin and his crew, we got The Expanse back. Oh, do we have a date for season 4 yet?
We don't have a date. I'm pretty confident it'll be this year, but it'll definitely be after San Diego.
Oh, so that's San Diego's in July.
Yeah, so it's definitely after that. I can't tell you because I don't know when, but my gut is pretty confident that it's going to drop this year. So let's wait and see.
Yeah, well, it just gives us a chance to watch the first 3 seasons over again until we really want you on the fourth. So, hey,
Yeah.
Kaz, I'm going to go ahead, man.
Keep an eye out for us. We're going to be going to Philadelphia Comic-Con.
Oh yeah,
and also FedCon.
FedCon in Germany, yes.
Back in Germany. That'll be in June, and I think Philadelphia is in April. And at both of these conventions, you will get large amounts of Expanse actors at your disposal.
Well, this is the Philadelphia Comic Con, right? Is that the official name of it?
I think it's called the Great
Greater.
Philadelphia.
Yes, I think I'll come to that. That sounds and that's in April?
Yeah, that's in April.
Okay, that gives me a good excuse to fly up to Philly. I
There
think,
you go.
yeah, I think I'll come on up there and just say hi to you. You're gonna be busy selling your autographs and hugging babies, and things of that nature. So
Get you back in a panel moderating us again, because that's always fun.
Well, that's not up to me. That's up to them. But we had a good time when we did it at Dragon Con. So
Yes, we did.
Other than that,
maybe
yeah.
we'll do it in Dragon Con.
Oh yeah, keep your fingers crossed. I know they want you. But anyway, we'll talk.
All right.
But other than that, thank you so much, brother. Really appreciate it. Love your character. Just love it when you're on the screen, man. And the good thing about it is you're even better in person.
Oh,
you are. You are.
All
right, man. You peace and love, man. We'll talk to you soon.
Thank you, brother.
All right, Cass. See ya. Bye-bye.
Bye.
And for all you guys that are still sticking up with us here, hold on real quick. I need to put up some ads here. Just want to go ahead and thank everyone that was responsible for what we had going on today. Where are my ads? I'm an idiot. Oh, here we go. Let's do this here. Boy, that's solo. Okay, guys, we'd like to thank the following. Of course, Colin Pelton, who basically helped arrange all of this. Maya Seidel? I think it's Seidel, Maya. I still see your face in the lobby, Maya, so you can wave at me. But I think it is Maya Seidel. Yeah, there you go. Amazon Video, Amazon Prime Video, for example. NASA, we want to definitely thank NASA. www.universeunplug.org. You guys need to visit that. And you can watch this broadcast again. It will be on the page that it is being shown from. So if any of you folks would like to see this broadcast again, you're more than welcome to watch this. I also want to thank Celestis, the company that I'm ambassador for. We actually do memorial space flights in terms of if you have any individual who has passed on and they would like a portion of their ashes to be shot up into space, you can contact Celestis. Go to www.celestis.com. Go ahead and look at our videos and how we've done it. We've been in operation for 20 years. We've done about 16 flights. We just did one from New Mexico. We're doing a huge one in April coming from the Cape. And yes, literally, if there are ashes of family members that you would like portion of to be shot up into orbit, we're doing a deep space mission later next year where we're shooting up the ashes of Star Trek creator Gene Roddenberry, his wife Major Roddenberry, and for a second flight, Jimmy Doohan, who portrays Scotty on Star Trek. We've also shot up ashes of some Apollo, Gemini astronauts. So that is a service that is available to anyone if you would like to be involved or like to be a part of that. Family members come and they watch the launches. Go to our website page and take a look at the videos, and you'll see exactly how that's run. It's very nice. It's very incredible, and it's very heartwarming. So do that. All right. My name is Mark. Middle initial B as in boy, Lee, L-E-E, and I am with MBL Entertainment Group. And this is what we do. We bring shows such as this to people like you and hope that you enjoy it. Thank you so much. I got to go get some lunch because I'm hungry. Bless you all. Thank everyone who has watched this broadcast. We love you guys. Oh my God, look at the comments. Yes, Melody, that's no problem. Cool. Chasm team did them. I'm just going through a bunch of these. A series of short episode, 5 minutes, blah, 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 blah. You have some really, really great comments here, guys. Screaming Firehawks, you guys rock. You are the best. You're just freaking awesome. Yes, the Habitable Zone, is that a film? Yes, it's a short film. You can find that on YouTube. Okay, You can find it on YouTube, read in the comments. That's no problem. Thank you, Garrett. Appreciate it. Doing it all for you, as Colin has said. Thank you so much for this time. Thanks all. Thank you so much. I got to go. Peace and keep expanding. I just made that up. Talk to you soon. Bye-bye. Have a great day.